It's got the hammer,
You get the brass for the hammer, and what else? One other piece of
the
it.
guide,
The key.
Yeah.
and then there's a key, and then there's
I'm going to Chiefs game tomorrow night.
There's
Last
slots
preseason
to
game.
go to that thing tomorrow.
It's just gonna be the first 5 or 6 who we grab tomorrow and go, so, yeah.
Yeah, I definitely want to go.
I definitely want to go.
Yeah, it'll be a good time. So we'll probably end class about 9:30 tomorrow, and then we'll head over there at 9:30. Take us a few minutes to get over there. So you just travel in your own cars, and then you can just leave after that. Yeah, and I'm going over there, and I'm coming back here. So, and then we'll go over there. We're gonna do some toolbox evaluation over at Stanley, and then just give them a little bit of feedback. And then we'll do a quick tour through the place, and we'll be done. So, all right, so Module 1 is week 1. And so kind of you just think about these things are due this week. Even if, since really everything's open, I'm not putting really time limits on the things that you have to do. So if you want to wait till the very end, you can do that. Here's how I would do things. I would work in the order that we're going to do them. Today we're going to be doing this PowerPoint, and so I would do this quiz after it. You did the general safety knowledge test. I want you to get 90% or higher, okay? So if you need to retake it, go in and retake it. You got 90% or higher, you can leave it. Now, what I would also do is, as we leave these open all the time, all the assignments will be open all the time, unlimited tries. So here's what I would do is when I found questions where I'm like, gosh, I'm unsure of what the answer is, once we hit on it, when we're talking about it either in classroom or out in the shop, I would be like, that's the answer to 12. I would go in there and resubmit that one. You know what I mean? Like, so you can go, yeah, so anytime, like, you could be you're like, oh my gosh, those are the questions that he just answered the questions from section 4, unit 2.
There's no reason.
And then go, yeah, so there's
90% in this class.
no reason that I mean, honestly, 101s are typically A's and B's. I mean, if you're struggling at C level, then you're probably gonna, it gets harder as we go, right? So, all right, so we're gonna do, this guy right here today, and we'll see if we can't just get it going. It's easier if I just download it and then go from there. You're welcome to grab a laptop, go along with me as I'm going. You can do it that way, or however it is that you want to go. So if you want to just answer questions in the quiz as we go, I'm okay with that. So yeah, and so the idea is that you're grabbing the information as we go, because we're going to be talking about this like 15 times, right? So it's not like a one-time thing and we'll never talk about it again. So I don't really care how you do it. All right, so here's what we're going to be doing. We're going to be looking at some definitions of machining and machine tools, machining and just how we work in normal life, looking at a couple of different machine types and some history of machining, and that one we'll just kind of quickly go over. Machining is using machine tools to cut materials to desired sizes and shapes. So we would call this subtractive manufacturing is oftentimes what it's called, okay? So when you're talking about 3D printing, it would be considered additive manufacturing, because you're taking something and you're creating it as you go. For us, we're taking a piece of material and we're kind of like sculptors, so we're taking everything that we don't want to be that piece in there, all right? And then a machine tool is just the item, the piece of equipment that we use to create what it is that we're trying to do. All right, so a history of machining. Humans, that's us, people, have used machine tools for centuries. Earliest machine tools were hand-powered, later powered by animals or water. Then went to steam, and then now we have ones that are controlled by electricity, which is much, much easier. So you go all the way to something like this, just a little slave labor. Then that kind of turns into something like this, a little more automated. And then you have something like this today. So 5-axis machining. And so we use manufactured items every day. There's not a day that you don't go through your life that you're using something that's been machined, right? So even if you're like, nope, all I did today was roll out my toolbox. I never even picked up a tool. I rolled it back in, and then I went home. I walked home and went to bed, okay? Well, that toolbox was made by machines, right? So sometimes it's the machines that make other things. So I tell students lots of times, we're not necessarily trying to be people who operate machines. We're people who set up machines, create programs for machines, do the next level stuff. If we're just being operators, I can usually show you how to do that in about 2 hours. So we want to be further along than that. Here's a couple examples of a shock and then some medical tools. I was at a conference a couple years ago at a place that did metal 3D printing, and they only made 3D printed stainless steel spinal pieces and hip joints. And I was like, how many of those do you make? And he's like, we work 7 days a week, 24 hours a day. We have 47 metal 3D printers that sit in a room and they print all day long. I was like, how many hips are needed? He's like, 47 machines, 365. He's like, apparently a lot. And I was like, that's pretty amazing though. So, oh, I'm sure they made
Those
tons of
3D printers pay for themselves, especially.
Oh, yeah, quickly.
The metal ones are pretty expensive, but yeah, I mean, the thing is,
Big ones now that do whole houses.
yeah.
How in the hell do you even hang it on the wall now? Because it's concrete. 3D
Right,
printed.
yeah, lots of anchors, yeah, lots of wall anchors, a lot of Tapcons. So, but yeah, like through metal 3D printers and stuff like that, additive manufacturing is super important to what we do. I think CNC will change into some of those things later on. I was at WSU Tech last year, and they had a mill that had a 3D printing head, came in and it 3D printed all the metal, it centered it, and then it machined off what it didn't need. And so, I mean, so you're talking about mill, basically heat treat oven, and a 3D printer all in one shot. This thing was giant. It's like as big as this room. It was super awesome. So you got molds. So again, things that make other things. And then not everything that we make is metal. So here's some plastic. We'll be machining some Delrin. Delrin is, and so when I say things like Delrin or Ampco or things like that, those are company names like Kleenex. You know, Kleenex is really a tissue. Delrin is really, acetyl is the actual name of the material. But, you know, Delrin is just the brand name of it. So, so if you see something like that's acetyl, then just know those two words, acetyl and Delrin, are kind of, they can interchange. So here you have a progression die. So when you want to try to make something like this, you can punch holes in it and then break it in a couple of different ways, or you can set it up in a progression die. And so I don't know if you've ever seen a progression die work. If you were to make, let's just say, a dog food bowl, that's not done. You don't take a flat piece of metal and hit it. You do it in like 8 stages. So you move that metal slowly because it wrinkles it, stretches it, and breaks it. So I got a video that I'll show you guys when we talk about safety. I'll try to do it today if I can think about it. It's some people that are in China. Have you seen it before?
Yeah, they're making pots and they're sitting in that.
Yes, they're sitting inside the press. Yes. So we would do it by automation.
Tight.
Yeah. Have you ever seen the video? Matt shows it sometimes. And you haven't seen it either. So it's these. They're definitely not Americans, and I mean they're literally sitting inside the die. So we would have done that with fingers and robots and some type of automation, so nobody's in there. These guys are just sitting in there, probably talking about what they're doing that night, and they're just like they just lean down and move it over, and I'm like, that's crazy, Oh, in other countries, I mean, it's very different than the country that we live in. Yeah. Right. Yeah. No rules. No rules. Yeah. Yeah. And so just to touch on safety real quick, one of the things that I have a friend who goes to China occasionally, and they have a big foundry, several big foundries that they have in China. And so how those places work is they're like a big apartment building, or kind of almost like a big factory with an apartment building in it. And it's all fenced off and keep people out and keep people in. And so what happens is, like, your family would move into that place, and then so maybe you've got the job, and maybe your brother wants a job there, and he lives with you, but he doesn't have a job yet. When they form these, when they use these castings, and the way they cast them, you take a negative, you pour the metal into it, and then cast, it cools down, they just dump them on the ground, and then they shake the sand off of them using rakes, and they rake them into kind of windrows so that they cool down slowly. If you were to fall into that, let's just say you fell into that and died, okay? Your brother-in-law or your brother or whoever it is would just be the person who was supposed to scrape you out of that, and then he would take your place.
Oh, wow.
And then they just move on to the next person, you know. And so places like Foxconn, anybody know what Foxconn is? So Foxconn makes iPhones. And so the place is so, it's so hard to work at that, so it's a giant, big, multi-story building, and they had to put nets on the windows because people would jump out of them and commit suicide. It's such a bad work environment. And so I don't care what your work environment is, it's probably better than some of these other ones out there. I mean, unless you're the guy back here, unless you're that guy, okay? I mean, that guy does not have a good, all right? So, but, I mean, you know, and some of these are kind of some exaggerations, but, so, you know, there's just a lot too. So if we go to Stanley tomorrow, you'll see when they build these toolboxes, they're not built in single breaks. Typically, it's often progressive breaks that make things happen.
I did ABB for a while. And
Oh yeah,
They
ABB.
do all
All their boxes.
process boxes and everything.
Yep, absolutely. Was that in Jeff City?
Yeah. I was a welder out there overnights, but then I was like, I had started my family. I was like, I can't do overnights anymore.
Sure. What's that? That is what that book is. Yeah. Yeah.
I never knew what this
Putting the
was.
pieces together.
I
Yeah.
bought all these books and I don't know what happened.
Yep. Yep. So it actually says, what's that say on the front of it?
Precision machining.
Precision machining technology.
And what class are you in?
I think precision machining.
Yeah, and so that's the link of those two things. I know it can be a mystery. I do. I realize that it can be a mystery, but yes, the book that you have for this class, and you'll have, just as a side note, you'll carry this book with you through all your semesters of machining. So you won't buy a different one next semester or next year. So it'll be same book through all 4 semesters of general machining. So.
It's okay to buy.
Yeah, so you can definitely follow right along with me. Here's a couple of molds, food container molds. I have a guy that I used to work with who was responsible for helping build a die that makes red Solo cups. And he's like, man, never did we think that we would build that many Solo cups. Now, how important do you think concentricity is? So concentricity would be sharing the same center line. So think things are they spin true together. Super important. So on a Solo cup, the wall thickness is only like 3/1000ths. So if you were to move over, if those two dies or two mold pieces weren't aligned, you end up with thick and thin, right? Yeah. And so you end up with, like, sometimes you have that happen, like you grab the cup and you're like, ooh, it's weak on this side. It's because of concentricity. So, so it's your die or mold setter for
As long
something.
as there's not a hole in it, they'll send it out.
Oh yeah, and probably I would say that what they do is some of that is there's a higher, well, I don't on most of the plastic you can't do that, but on, you know, there's levels, there's quality of cup. You sometimes you go to the expensive party and it's got the strong Solo cup and you're like, yeah, these guys spent some money. And then you go to the other ones where you're like, don't squeeze the cup, right? Like, you know, I mean, that one came straight from Walmart, you know. The other ones came from somewhere else. Yeah, exactly. All right, so let's look at a couple of different types of machines. There's really kind of 2 standard machine types. You have your basic conventional or manual machines. And so this says requires a human operator. Yes and no. Same thing for our CNC machines or our automated machines. So conventional or manual machines, you're doing the work or you're doing the movement. On a CNC machine, it can do the movement by itself. But at the same time, I would say there's times where we will run a CNC machine just like a manual machine. Yeah, the shop I came from, we had rows of manual machines that we did not use anymore because if we had to make, I don't think I have any parts in here. Let's just say we had to make a ring like this out of a piece of aluminum, steel, brass, bronze, whatever. We would have done that on a CNC machine rather than going over to a manual machine, even if we just had to make one. Because our guys were fast enough that they could make one on a CNC as fast as they could make one on a manual machine. And you get to use insertable tooling, and it controls all of the mess and coolant, and it's really just more efficient. So it's about choosing the right tool for the right job. You know, if you have one wonky hole to put in at a funky angle, manual machine's the way to go. If you're going to drill one hole on a piece of steel or a piece of material, maybe the lathe is the way to go. So there's the right thing for the right thing. So you want to make sure you know what those are. There's a bandsaw. We got a chance to start to use it yesterday. Several different kinds of bandsaws in the world. This is a horizontal bandsaw, and it's a bandsaw because it's a band, right? So they have power hacksaws. They have all kinds of different saws out there in the world. This is a vertical bandsaw. We used it a little bit yesterday as well. We'll use it more as we go. Here is a circular saw. We will never use it. Typically, you'll see people doing some slotting and stuff like that. We don't have anything like that. Honestly, I've never seen one in real life. I see vertical and horizontal bandsaws all the time. A circular saw like that? Really?
Yeah.
Not like a-
I'm sure he said he got it from some college because they couldn't figure it out.
Oh, okay.
Something broke on it, and he got it like super cheap.
Okay.
And he rebuilt something on it.
Cool. All right. So then we also have automated saws. So you have a CNC sawing machine. And remember, CNC stands for computerized numerical control. So it's some type of programming system for it. Drill press, manual drill press, and our drill presses, they're not really like this. I mean, same functionality of them, but they're newer than this. Ours are variable speed, but what you want to make sure, they're kind of the one hiccup that those machines have. They got a high and a low and variable speed, so you can just adjust the speed on the fly, and they have a tapping cycle on them. They're super slick. The one and only problem is if you turn it off and on several times, it will stop because it doesn't know what you're doing. And if you're turning it off and on like random, like rapid fire, it's like, is there a problem that you need to stop and figure out? And so it's just going to wait for a second. So if that happens, turning the power off isn't necessarily going to help you out and reset it. Give it a minute. It will reset, and then you can go back again. So I would say don't turn it on until you know what you're ready to do. Okay, so don't just like random turn it on and then be like, oh man, I need to be in low gear. Then turn it off and switch in low gear, and then turn it back on and be like, oh my gosh, I put the wrong drill in. Turn it off and put the right drill back in. Turn it on, and, oh my gosh, I need a tap instead. You know, and then, yeah, just like take a minute, get your bearings, and do the things you need to do. And so really, I think that's good practice for everything. Here are just a handful of machine parts. Throughout your time here, we'll make several things. Our 118s, they make an aluminum chess set and some other things like that. If we make some cool stuff, we'll make some not cool stuff too. So some of the things that we make are widgets for specific things, like I need to see you drill something, tap something, counterbore something, countersink something. I need to see you do those things and make sure that you can do those things on a real part, you know. So if you can do it on a blank piece, like so the drill press project, you need to make sure you can do that. And then if you can do it there, then you should be able to do it on the next part. So some parts are widgets and some parts are actual parts. So our manual lathe, it's a Harrison M500. It's a English machine. I ran one similar to this for quite a while. When I started on manual equipment.
That's what we had at capital machine in Jeff City.
Okay. Harrison's a good company. And then we have our CNC machines. These are our automated machines. And obviously you've seen both of the differences out there in our shop. And then we have the manual lathe the manual mill versus the CNC mill. A a lathe is doing the same functions, whether it's manual or automated CNC. A mill is doing the same function, whether it's automated or manual. A couple different styles of grinders. This side is a surface grinder. This side is a bench grinder. Even though they're both called grinders, very different things. Okay. Yes.
You have any live tool lathes in here?
Yeah.
A lot.
So we have. Well, no. Sorry, we have two. It's the two right through here.
Oh,
So those two are live tool and Y-axis. I've got 4 more on order. But there is a slow cycle to get some of these things worked through the system.
live tool lathes are like a mill and a lathe.
Mill and lathe. Yep.
They have a drilling.
So ours do not only live tools this way, and they Y-axis. So you can mill a complete square part on the lathe with holes all the way around it and diameters on it. So really, I always started to say, I started to say about 2 years ago, if we just had live tool lathes, we could do any parts that we wanted to, because you could do all your milling and turning all in the same shot, depending on the size of the part that you're working on. So I have a friend who makes square parts on his lathe, and that's all that they do. They only make small square parts for Swisher mowers, and that's all they do is make square parts, and he runs a lathe, and you would think that he would run a mill with it, but it's lathe all day long. Okay, so surface grinder, bench grinder, very different things. This can be used for deburring, drill sharpening. This can be used for that too. This is for high precision grinding, okay? So mirror finishes, this is for pretty rough stuff. So when we get to 103, we start doing some grinding in 103. These are both called grinders. They are very different pieces of equipment. EDM, anybody know what an EDM is? It's an electrical discharge machine. And so it uses electricity and a wire about the size of a thread. And so what it'll do is you take a plate, typically you'll heat treat it, surface ground the top and the bottom, have a little start hole for it. It'll cut the shape out using electricity. Kind of works like a bandsaw, but it doesn't cut. It just uses electricity to it. And it holds plus or minus 1 dimensions like a bandsaw. So like we had one at the shop I came from. And so like you wanted to make a punch like this, if the dimensions on it were plus or minus 1/1000ths, I would set it up. I would have it run while I was gone overnight. They're incredibly slow. Come in the next morning and I'd pop the punch out and I'd never even check it because I knew it would. I mean, that's like sawing for it. It's just so, a thou is nothing. It's not even worth checking because you know there's no way it's not going to be within a thou. But so we would split tenths, sort of 10,000ths of an inch on that machine all day long. And I mean, it's a beautiful, beautiful machine. We don't have any because they're extremely expensive to run. They're extremely slow to run. And since everything comes out perfect every time, you'll just have a line of people wanting to run that machine. Nobody will want to mill anything or turn anything. They'll be like, I'm just going to do mine on EDM. And I'm like, that's just not always practical to do. So
Not every shop's gonna have one.
yeah, most shops don't. Here's an EDM sinker machine. This uses a electrode. You machine the shape that you want, and it just uses electricity to drive it into it. You ever seen those things that have all the pins in it, and you put your face up to it, and it pushes your face through there?
Yeah.
And it's just like that, except with using electricity. And so it'll just cut that shape into it. So you can make an electrode of your face, and then you could just EDM it, just use electricity to just drive that into it. And then you can make a mask, or you can just do whatever you wanted. Have a positive, have a negative of it, you know. And so whatever the shape is, that's what it puts in it. So it's really cool.
It's kind of like a mold, but
Tried it? No, I've never tried
so
it.
close, but it's kind of like a mold type thing.
Yeah, a lot of times people will use those for molds. One, because they also don't have any tool marks on them. So there's no milling marks or anything that gets on them. It's totally smooth.
Everything's good to go.
So they use, EDM sinkers use a dielectric fluid. It's an oil. It's not uncommon for them to catch on fire. Now, a wire EDM uses deionized water in it. Everything's done underwater. So you can run the machine, electricity, I mean, you can see an electric, it looks like it's welding through there, but it's really cutting. It's water I would take my hands down in there and I would measure dimensions on parts while it was running in the water, because it's totally deionized. I would not recommend doing that, okay?
If it becomes otherwise.
If there is a potential danger that comes from it. So like, don't make that your habit, okay? So, yeah, I mean, you'll end up getting electrocuted, pee your pants. It's gonna be really embarrassing for you, so don't do that.
You never know what's gonna happen.
Wasn't personal experience, I'm just saying, I know it can't happen. So here's kind of how the EDM works. It has this, like I said, typically it's underwater. It's gonna cut the shape out, so any of these shapes, it would just cut out, so it can make that in one shot, making that V block, and it'd be perfect in size and shape. And, okay. So then here's just a little laser. Laser and plasmas and water jets are kind of all the same, all kind of that, basically 2D shapes.
How many PSI is a water cutter making nowadays?
I don't know. I mean, it's such a ratio, sand to water.
Yeah.
And
It
so,
causes erosion, but at a very fast pace.
oh, totally, yeah, yeah. But yeah, I mean, I think that, I've never ran a water jet. I mean, there's one up the road here over, Parkhurst. But, really, if we have anything done, or usually when I see people do stuff, they're having them lasered. And, there's a couple shops around town that do lasering, and, lasering's pretty cheap.
I don't know why people do water. I don't know what the whole, like.
Cheaper to run.
High pressure, is it just cheaper to run?
Probably cheaper. Yeah, and you can go right down the drain. Yeah.
There's no waste
I mean,
material
I've
left.
seen it, it's been out for a little bit. But
Oh, yeah, they've been around.
I don't know how much the technology is.
Yeah, I'm sure it's probably advanced quite a bit.
You can take a rock, literally, put it in the machine, and it'll cut a rock out.
Doesn't care.
Whatever you want.
Now, that's the, kind of back up just a little bit on the EDM, it can only cut things that conduct electricity. So you can't EDM plastic, because it's an insulator. But you can water jet plastic, right? So, I mean, it's kind of about choosing the right thing for the right thing. So, all right, let's see.
I have this quiz.
Yeah, I got the quiz open too, but half the stuff I didn't catch through the whole time.
How many inches of steel can a water jet machine
That's the
cover?
question I just asked you.
How thick?
Yeah.
Yeah.
I don't know, you probably have to look.
6, 8, 10, or 12. It don't say in that
I
slide.
don't know, you have a book
I'm saying, so we gotta have the book.
that has some of those things in it. So here's what I'm gonna do, I'm gonna stop the video.